Hi, my name is Kelvin Newman and welcome to the Brighton SEO podcast, where we share talks from one of the world's most popular search marketing conferences. The event started out as a few people meeting in an upstairs room of a pub and is now attended by over 3,000 people from all over the world. This episode is a recording of one of the speakers at a recent event. So I'd really like to welcome to the stage our first speaker, Peter. If we could give him a big round of applause, everybody.
Hello, it's nice to meet you here. And today we'll talk about quick and dirty server-side tweaks to improve your SEO. So my name is Peter Nikolow. This is my social profiles where I'm typically active in Twitter, mostly in Facebook. So today we'll talk about this. So you make a website. Site is work very well, and suddenly something happens. So you in this way, you see a hockey stick of users, bunch of users, and probably some of you observe this. And today we'll talk how your site can survive this, and analytics will not going down to zero if your server crash, how you continue. First, we need to talk about website architecture a little bit. So we have a web server that handles requests, but that server pass requests to language. And this way, many of this auditorium use the PHP language. So this can be PHP, can be Perl, can be Ruby, or things like that. Language execute the CMS core, and CMS core load the plugins and themes how to work, and they both make a request to database server and to the database. Later, when CMS compose the HTML page, it returns to language, that returns to the web server, and this is returned to the users. Meanwhile, for server, it can pass static files. This is, for example, cascading style sheets or JavaScript files, but they are static files, and even also images, and even single bit of them isn't changed from the web server because they are static. So, how to start? Good optimization start with database optimization. This is where most fail. You should note about database because less is more. Many people try to fill into database too many data, and as a result, database become larger and become bigger. And it's okay because it's also make database slow. For example, I have seen many developers who even insert images into the database. This is not for database. Database is just for data, not for files. So please note, less is more. Less data, database will be faster. Second, almost all of e-commerce system and all CMS use EAV model. EAV means entity, attribute, value. This is perfect for holding non-structured data into database, making database faster. But as a result, you use database become larger. I can give you an example for that, but if you have a structured data, you make the table for that data. When your data is unstructured, you need to make the developer's way to insert unstructured data into database, and all of them use EAV model. Next, please remove all useless data from database. In my experience, I have one of example for that. So I have a customer with WordPress that become slow, very slow WordPress. So with 5 minutes, I remove almost 1 gigabyte of database data from that database, and database become WordPress is remain functional, but I remove almost 1 gigabyte from this because some plugin fill database with useless data, and as a result, WordPress was suffering from that. Next, please not use a test server. Because if you didn't test, all changes in database are irreversible, and you can push on the button to bring database back. So you need a test server for playing with that. And for the only way to use this is to use another system just for testing and for playing. You also need tools for fine-tune database. In my example, you need to use a MySQL tuner. And here is it. I have MySQL running for 8 days. And this is how are the things. You need to know this one. This one is one of very important thing. If you didn't give to MySQL too much memory, MySQL create for some of its operations where joining two tables or more tables, MySQL doesn't have enough memory to hold a result database. So for example, MySQL create temporary file on disk with that result database, and once operation is gone, they trash this database. So for your example, if your memory is low, you will see that you have too many temporary files created on disk. By the way, this is one of the reasons why MySQL is performing much faster on solid-state disks than on hard drives. You can see that I have enough memory for that, but unfortunately, I will just scratch a little bit the surface this because I can give you scenarios about that because I don't know what e-commerce system you have, how many memory you have on that servers. So I'll just leave that, and you should know that there are tools for getting maximum performance on MySQL. Another way for speeding up your tools is to use in-memory database like Memcached or Redis. That database works just in memory. They don't store even single bit into disk, and that's why they are faster. Now, bad news, they require much more memory to hold that data inside. So, information here is a lot, and this is everything I can help you because you know there are some kind of sets like database administrators, and they are going to ask you many questions. What is e-commerce system? How many memory you have? So I'm sorry, but just a little bit scratch on the surface. You need to know what is your database and on what system you will run this. So this is everything I can give you as examples. So great optimization is about the web server optimization. So how many of you use Apache web servers? Okay, that's great. Dirty secret, it's that Apache, you know, there is htaccess file when you can control this. And dirty secret is Apache is slow because of use of htaccess. For each request you made to that server, it loads the htaccess, it executes it, and on second request, htaccess is loaded and executed second time. So for each request, you load file, parse, execute, and that's all. That is one of the reasons why Apache is a little bit slow compared to the other systems. Unfortunately, if someone brings you a web server without htaccess, most probably will be freaked out. Second dirty secret is that Apache, if you have a low override directive in subfolders. So imagine that you have a website and folder 1, folder /folder 2 /folder 3, or things like that. And there is a JPG file. If you allow override in root of htaccess, Apache will gonna start to look at htaccess in each folder about that. And this is even Apache. This will make Apache even slow because for looking about that files. They can exist, they can doesn't exist, but no one can help you because Apache will gonna look for them. There is one solution you can fix this slowness. if you make a patch configuration static. Just need to put all your htaccess file in this file, http.conf, so a patch no one gonna look anymore for htaccess file and will become faster again. Second big problem in loaded busy server is when you enable on-fly compression using deflate or gzip. This is great, works very well, because this minimizes the data that web server transferred to the client. But there is one dirty secret, because for each file, web server load it, compress it, and then pass to the client. So this make few things. First, it increase time to first byte to the client, because need to be compressed. Second, this required memory for in-memory compression. And third, this load much more server because this compression. So next secret is that if you have 5 CSS files, so on each request, you're gonna compress that file, send to the customer, and when next client, for example, next client asks for same file, it will be compressed on the fly again for you. There is one fix. For fixing that on-fly compression over and over. First is to make your static files already compressed. If you make this, web server will send already compressed file to the client. If some client doesn't support compressed file, you will send it uncompressed file. Second, you can make some kind of DNS like static.example.com, where you can serve only static files. They will be probably already compressed, and that's all. So using that trick, you can save probably more than 50% of your CPU usage about that. This is a little bit tough because all the SEOs love Apache and its redirect directives about making redirects. So redirects is another way to make your Apache server slow, because if your htaccess file become larger, you will slow down server. And since almost everyone uses that redirect, too many redirects can slow down your website. There is one way to fix this, is to use a redirect map file. All servers support redirect map file. Once you make redirects, you make them in some kind of table, and this is permanent. Apache loads this redirect map file from memory and doesn't reload for each request, so this is one of way to make redirects faster. Also, this is one of way if you make like 10,000 requests or 1 million redirects, this is only one way to make that redirect, using redirect map files. So we'll talk more about Apache, but Apache is over almost 30 years old, and Apache isn't supported very well for modern web servers. For modern web servers, there are few web servers that can handle one of the biggest problems in computing. It's called 10,000 concurrent connections, so C10K. One of the reasons to create that is for that servers use another web server architecture, another computing architecture, and that server required much more memory. They are much faster, and they can handle 10,000 concurrent connections. With Apache, you can also handle 10,000 concurrent connections, but you need much more processing power and much more memory for handling that. So you can use Nginx, you can use Lightspeed, and you can use Lighty. There are one of those servers that can handle 10,000 concurrent connections to one website. So another way is for accelerating servers is to make reverse proxy server or web server accelerators. So one of them is called Varnish, but Varnish supports just HTTP. unsecured, and there is an extension called Hitch just for encryption traffic. You can configure also Nginx as reverse proxy, and you can use also Nginx with microcache architecture. And here is one of tests. So if you have WordPress on a patch, we can make about 5.5 requests per second. If we make WordPress on a patch and Nginx as reverse proxy, we can handle 5.6 requests per second. Now, here is the trick. If we enable WordPress with Nginx with basic microcaching, we can handle 600 requests per second. But we can go even further when you enable WordPress with optimized microcaching. So this is actually limited for network card, but we can observe like 3,000 requests per second about that, just with one single change of your web technological stack. By the way, Varnish that we talk about, Varnish can give you between 5 or 10% better than Nginx. I'll just leave numbers here because if I add Varnish, it will become too complicated. So that's it. So next one, there is a encryption today. And everyone is pushing web to the secure internet. One of way to accelerate your encryption is to use elliptic curves. With traditional TLS handshake, we can make about 3,000 handshake per second. If we just enable elliptic curves with elliptic curves handshakes, we can observe up to 30,000 handshakes per second. On same hardware, you just set your configuration for elliptic curves, and you can see that. Second, please disable secure socket layer version 2 and version 3. They're vulnerable. They can be broken very quick, so disable it. Use just TLS. By the way, this is one of the problems because everyone is talking about secure socket layer today, but today there isn't secure socket layer. Today we'll talk about TLS, but just people talk about SSL. Next, you can AES NI instructions on all new computers. This is just for accelerate your AES encryption. On processor that doesn't support this encryption, you can observe like 19 megabytes per second. But if you enable just instructions, you can get to 550 I don't know, honestly, megabytes per second, almost half of gigabyte. Next, you can use AVX and SHA instructions. Currently, it's fast, but if you enable AVX, you can get 300 megabytes per second. And if you have a processor with much more, with new instructions, SHA, you can get 600 megabytes per second. As I say, no changes, just you need to know, do your server support that instructions and to enable it. So ground optimization, it's continued with network layer optimization. So we'll talk about a little bit TCP. TCP is the main protocol of the internet, and it's worked very well for over 14 years. It's amazing because it's bandwidth adaptive. You can have Internet of Things from last client, you can have laptops last client, you can have something. Doesn't matter because it's bandwidth adaptive. So one of the reasons is that you have TCP slow start. The client make the request to the server with one packet, and server split a request to 3 packets because response is too large for 3 packets. So it's split to 3 packets and sent back to the client. The client responds that he received that 3 packets. Server sent another 3 packets of response. On next answer, server already know that client can handle 3 packets and start to send in 6 packets at once, and this is called TCP slow start. One of fixes is to make TCP to start with, it currently starts with 3 packets to start with 10 packets. So how this gonna work? By the way, this is one of the reasons why HTTP version 2 is faster. As long as you continue make to the server, that's fast, it's gonna be accelerated. Because first you get 3 packets, 6 packets, later you continue to 12 packets, 21, 33, 51. So this is why you should make a long connections to server, not to make a request and close that. Leave connection open so TCP and HTTP can be adaptive to your needs. Another way to fix to TCP is to fix to TCP congestion control. Since we know TCP is slow, that is first way for congestion between client and server. And today, there are over 20 algorithms about that. Today is used PRR, New Vegas, BBR from Google and for Facebook. How this works? So we start connection, and meanwhile, we lost 1 packet. So TCP start again from beginning, from 3 packets, and then again accelerate window. This is Tahoe. For Reno, you also get a little bit penalty, but you can recover much faster than in Tahoe. In other protocols that we're talking about, like PRR or BBR, recovering from packets lost is much better and much faster. Next one is TCP handshake. This is traditional way for handshake. The client sends SYN packet to the server, and server acknowledge with SYN ACK to the client. Then client make ACK and attach a request in new packet to the server. Server responded and sent response to the client. Today, we have TCP fast open. How this works? Initial, you also make TCP three-way handshake. You send SYN and TFO cookie request. If server support TCP fast open, server respond with SYN ACK and send us TCP cookie. Client again send ACK, and connection continue just like before. But if you make secondary request to that server that support TCP fast open, you send SYN TCP fast open cookie that client stored, and you send a request in first packet. You send it to the server. Server sends SYN ACK. Meanwhile, a request is sent to the application level, probably web server. Customer send the ACK, but meanwhile, since request is sent to the web server can respond much faster to the client. TCP fast open currently is available on almost all operating systems, since it's launched on Windows before a few months ago. In Linux, over 5 years, they have this. So, one of reason to fix, we talk about congestion, we talk about TCP through handshake, but we can't fix anymore the internet. That's why Google created a brand new protocol that's called QUIC. QUIC, it's next level at HTTP level 2 because it's run on UDP. So, how works TCP? You make handshake to the server and later you send data. That's great. With TCP and TLS, you make TCP handshake to server, you make TLS handshake to the server, and then you can send your data. When you have a QUIC on initial request, you send everything, and server already have it. So, how is it? You say client hello with QUIC parameter settings on first request, you send it to the server, server received and say you server hello, and send to the client. Then client, once you have encryption, client can send you your application data. But If you have quick on reusing connection, you just send application with get to the server, and server can receive it on first packet. So the future, the future is now. It's coming soon. The future is quick. Quick is 2 years ago, Google invented and put it to the Chrome. So please listen carefully about quick, because quick soon will land on computers and will smash everything. Second, watch out for TCP 1.3. We are talking about TLS. About TLS 1.3. So many Linux servers will deprecating TLS 1.0 and 1.1. So we will remain just on 1.2, and TCP 1.3 is on draft. Probably next year will be released. Probably, no one knows. Also investigate a new way for compressing the data with Brotli compression. Brotli is new way for compressing. It can give you 30% better compression than gzip. On side note, it requires 1 gigabyte of RAM for compressing and required a lot of time for compressing. So it's good if you just compressed static files, not for dynamic files. For dynamic, you can use gzip. So next, please. You can as you can see, we talk about dynamic pages. You can learn a little bit about the static sites, because static sites, they're always faster. You can deploy them almost everywhere. So you can use some of static site generators for smaller sites when you don't need CMS for publishing the news. And the last one, you can use serverless hosting. Serverless hosting is new hosting, but some of you use mobile application development, things like that. Sorry. So Google make a Firebase for that. You can use Google Functions or Amazon Lambda. Serverless hosting means you deploy your file somewhere over cloud, but without processing that, without server, without dynamic pages. So it's a little bit like static sites, but nowadays isn't server. And last one for today. Honestly, almost everything that I talked today, you need DevOps who is skilled for deployment about that. That's why DevOps are true SEO heroes, because they are low-level technical guys that you need to use their skills for deployment servers and bringing you to the next generation of internet sites and speeds. So that's all. Thank you very much. If you have questions, you can find me on Twitter on Peter Nikolow. That's all.
Thank you. Cheers. This was originally recorded at a Brighton SEO conference. If you want to listen to more episodes or find out about the conference itself, you can do at brightonseo.com.